sensory nerve conduction study. The tested side and nerve are indicated at the top in the result table. The amplifier and display settings are shown at the top in the trace area. The display gain is 20 microvolts per division and the sweep speed is 1 millisecond per division. The stimulator settings are shown at the top in the toolbar: the stimulus duration, stimulus intensity, and stimulation rate when a recurrent mode of stimulation is used. The stimulus intensity can also be seen in the status panel in the bottom right corner when we begin testing. Connect the recording electrodes to channel 1 input of the amplifier and turn on the amplifier if necessary. The monitor trace shows the signal baseline. It should appear flat, indicating minimal noise and interference. Sometimes in the sensory nerve conduction, one may get significant power line frequency interference. This can be attenuated by using the so-called notch filter. The filter can be turned on by clicking on the icon in the toolbar. In this recording, we have a very nice flat baseline, and therefore the use of notch filter is not needed. The first stimulation site is selected. Stimulate and increase the intensity to record the sensory nerve action potential. The response is marked automatically. Marker 1 is placed at the onset of the response. The latency of this marker is shown in the result table: onset latency 2.19 milliseconds. Marker 2 is placed at the peak of the response. The latency of this marker is shown in the result table: peak latency 2.92 milliseconds. Let's look at the amplitude measurements. The voltage difference between markers 2 and 1 is the negative peak amplitude, and in this recording it is 44.2 microvolts. Marker 3 is placed at the positive peak. It is used to measure the peak-to-peak amplitude. The voltage difference between markers 2 and 3 is the peak-to-peak amplitude, and in this recording it is 66.4 microvolts. In this system, we have configured a default distance for the first stimulation site, 130 millimeters. Using the onset latency of 2.19 milliseconds and a distance of 130 millimeters gives us a conduction velocity of 59 meters per second. To stimulate at the next site, push the next trace button or key on the console or stimulator. Stimulate and record the response. The positions of the markers, placed automatically, can be changed manually if necessary. Also, the default display gain and sweep setting can be changed if necessary. In this case, I'm going to change the time base from 1 millisecond per division to 2 milliseconds per division. Measure the distance between the two stimulation sites using appropriate units, millimeters or centimeters. Type the value using the computer keyboard and press the Enter key. Note the conduction velocity. Repeat the process for additional stimulation sites and then exit the test.